Welcome back to this second video on types of plots and in seaborn. In the previous section we look at scatter plots, and we say that scatter plots are very important if you are looking into the patterns and relationships in data. As a data scientist, you might come across huge data sets that you want to know how these data points or each of the rows or each of the data points are concentrated. So in that case, you will probably use histogram, and histograms are special kind of bar plots that we previously looked in our other section that basically counts or shows you the count and the frequency of the data point within equal intervals. So I know the explanation doesn't make very much sense, but once we start coding it, you're gonna see how the explanation surface. So the whole purpose of using histograms is to ensure that you understand your data, and it's also a good detector to know the outliers in your data or even anomalies that might arise. Some of the anomalies might be maybe just the normal nature of the data, or sometimes it might be an error in a data set. So maybe you are dealing with the height of kids, or maybe the data that you have is height of all children born between maybe the last 6 years, and you find a kid that is 6 feet tall. So that is not normal. So maybe it was an error in the data. Or sometimes maybe you are expecting that somebody to be this amount of age, or this is the age of the person, but apparently you just find an abnormal age in that data set. So it will basically show up in when you use a histogram, and that is why it's a very important tool to understand. So as is the custom, when you want to use seaborn, we will import it. Import seaborn as SNS, and that's it. And then we're gonna use the data set. Again, I provide the data set is the same data set that we have been using. So we read it as a CSV because it's a CSV file. It's traffic.csv. And then let me just show the first few lines to ensure that I'm reading the correct data. 5. Can run it. So this is our data set. So I want us to plot the distribution of the speed that each of these drivers who are recorded for the offense were driving. So to do that, histograms or seaborn allows you to basically draw a histogram by a single line of code. So the function for that is called histplot, and it accepts the column. So in this case, I'm just interested in the speed column, so I'm gonna do the name of the data frame df, and then opening and closing square brackets, and then have speed, and then I have the KDE. So KDE basically means kernel density estimator, and it estimates the probability density function of the these random variables. It's not random in this case. Okay, I generated them randomly based on the weight. So I can make KDE to be true, and then beans basically represents how many groups you want to have as your histogram. So in this case, I'm gonna have it as 10. So this will draw a very nice histogram, and you can see the output. So it basically tells you that between the speed of 60, there were only 2 people from our data set, and you can see here there were 2 people. It has counted that very well. Between most speeds are concentrated around 100, and around 10 people are recorded at that around that speed. So you can see 10 at 2500, other 800. So basically it shows you the distribution, and very few people are driving at around 140 or 120. So these are very important when you're just knowing the general trend of your data set. One more thing that you need to know is this kind of data set or this kind of distribution is normally known as a normal distribution. And what happens is most values are clustered around the center, and then they tapers off as you move away from the center. So as you move towards the left, the values reduces, towards the right, the values reduces. And this is very common in nature, or even within our society. If you make biased sampling, you realize that it will always follow this distribution. A good example would be if you start sampling the height of, or let's say the weight of an adult. Of course it depends with the continent, but if you sample the weight of adults, you realize that mostly they'll range between 60 and 80 kgs, and very few adults will be below 50 and 40, and then again very few people or few adults will be above 90 or even 100. So in that sense, you will have a normal distribution where the average, most population are concentrated within the average, and then less below the average, and more, and again less above the average. So that is to do that. So in some cases, in other cases, it's not normally the same. It's not given that you will have a normal distribution. And to illustrate that, let me use the total amount column to generate the histogram. So I'm just gonna copy this, but instead of having the speed, I'm gonna use the total amount and then run it. So clearly you can see it doesn't look the same as this. So most of the values are concentrated to the right, and there's kind of a tail, and this kind of distribution is normally said to be, we can say that the data is positively skewed, and or if you don't want to say positively skewed, you can say is right skewed distribution. And it's right in the sense that the tail is towards the right. So the direction of the tail is what tells you whether it's positively or right skewed or left skewed. Don't look at where the concentration is high. Where the tail winds off is where you use it to name the graph. So this is a right skewed distribution. So it means more people are concentrated here, or most of the amounts are on this side, and then it tapers off as you go towards the right, and that gives it the name the right skewed. In some cases, instead of using the hist plot, seaborn allows you to use another very simple function called displot. So I can use d instead of hist plot. I can use this plot and then just use df. In this case, let me use speed because I just like the normal distribution of that data. And then kde, I'm gonna have true, and then beans, I'm gonna have 10, and that's it. And you can see it's clearly the same as when we use the hist plot, except that now it omits this kind of having lines on both the four sides. So I kind of like this than this, but it's your preference. You can select the one you like. You can use this plot or hist plot, but the whole idea is it shows you the frequency of your data points. So that's to do with histogram. If you have any questions, please leave them on the comment section. Again, subscribe to the channel so that when the new video comes up, you are notified. Again, tell a friend to tell a friend. Come and go together. For now, bye bye.